Welcome to this video on making mistakes when solving systems of equations. Let's begin. So in this example, we're going to solve the system of equations by using substitution. Please note that everything I'm going to teach you about making mistakes applies to both methods, both substitution and elimination, which is also called addition. Okay, so I'm going to start out by doing this correctly, and I'll show you exactly when and where I intentionally make a mistake so that you can see at the very end what that's going to look like. Okay, so if we are using substitution as the question asks us to do, that means that we have to pick one of these equations and isolate the variable. So I'm going to pick negative 2x plus 4y equals 12. Okay, and I decided that I want to solve for, let's see, I guess I'll get 2x by itself. So in other words, I'm going to subtract 4y from both sides of the equation. Okay, so that gives me negative 2x is equal to 12 minus 4y. Okay, and then I have to divide everything by negative 2 in order to isolate my x variable. So I have x is equal to negative 6 plus 2y. Okay, so here's where I'm going to intentionally make a mistake. Let's pretend that I forgot, right, that negative 4 divided by negative 2 is a positive number, right? So let's say I make a mistake there. So instead of what should be there, which is a positive 2y, right? Let's say I accidentally write a negative 2y there. Okay, so there is my mistake. Okay, so that's step one. I've isolated my variable. So step two has us picking the other equation, which is 5x minus 6y is equal to negative 14. Okay, I'm going to trim this tail up a bit because it's kind of in my way. Okay, so 5x minus 6y is equal to negative 14. Okay, in place of x, we are going to write that expression, negative 6 minus 2y. All right, so now we have 5 times negative 6, that's negative 30. Then we have 5 times negative 2, that's negative 10y. So then we have minus 6y equals negative 14. Okay, so we have negative 30 minus 16y is equal to negative 14. Okay, so we're going to add 30 to both sides. So we have negative 16y is equal to 16. Okay, and then I'm going to divide both sides by negative 16. Okay, and we get y is equal to negative 1. Okay, so notice that so far, right, I have, I still got an integer value for y even though I made a mistake. Okay, so there's not really any red flags other than the fact that I already told you I made a mistake on purpose. Okay, so in step 3, I can pick either equation, it doesn't matter which, and put negative 1 in for y to solve for x. Okay, so again, you may use either equation. I would like to use negative 2x plus 4y is equal to 12. Okay, and in place of y, do that so we don't get messed up here, negative 2x plus 4 times negative 1 is equal to 12. So we have negative 2x minus 4 is equal to 12. I'm going to add 4 to both sides. So we get negative 2x is equal to 16. Divide both sides by negative 2. And that gives us x equals negative 8. Okay, so again, I want to reiterate, we've gotten an integer value for both x and y. So, if I were going to skip the step of checking my work, I would think, oh my gosh, I have this completely correct, right? And I would probably feel secure in my answer, and I would move on to the next problem. Okay, so let's check our answer and see what happens. So remember, in step 4, we cannot use the equation we used in step 3. Right? We can't use negative 2x plus 4y equals 12. We must use the other equation, which is 5x minus 6y equals negative 14. Also, I want to remind you, right, the only time I used this equation, right, was in my substitution, right? And every time I've picked an equation, I go back to the original problem. Okay, and that's really important because if you keep using this equation that you modified, you're not going to ever find your mistake. Right? Because if you use your mistake to check your mistake, do you see what I'm saying? You're never going to find it. So you always want to go back to your original equations that the problem gave you in the first place. Okay, so let's go get to the exciting part where we actually check our work. So we said x is 8, so we have 5 times 8. minus 6 times negative 1 equals negative 14. So we have 40 plus 6 equals negative 14. So we have 46 equals negative 14. Okay, so hopefully we can all agree that 46 and negative 14 are not the same number. So this is a false statement. Okay, so a big point of confusion for many students is that I've taught you when we do these problems and you get a false statement, right? Well, that just means that you have no solution. Unfortunately, that isn't true. It's only when you get a false statement in step 2. Okay, right? Remember, what is step 4? Step 4, we're not finding x and y anymore, are we? Right? Step 4, right, is really an extra step to just check our work. So if I'm checking something, right, think about it if you're like balancing your checkbook or you're adding up receipts or something, right, and your numbers don't add up, you get the wrong result, right? That doesn't mean there's no solution. It means you made a mistake. You have to go back and find it. Okay, so as soon as you get here, if you get a false statement, right, like some number equals a different number in step 4, okay, this does not mean no solution. So please, please, please do not write no solution here, right? That can't be true because you already found a value for x and a value for y, okay? So what is true, however, is that we made a mistake. And again, we know that we made the mistake right here on purpose. So it's x equals negative 6 plus 2y, right? And if I had put that expression in, then that would have given me the correct answer. So on the next page here, I have completed the problem correctly. Okay, and I don't really want to spend time on this video. I don't want to make it last forever. But the important thing to see here is that when I check it, right, that I have negative 14 equals negative 14, right, that does not mean infinite solutions, right, because it didn't happen in step 2. It happened in step 4 after I had already obtained a value for x and a value for y. So my final answer, again, is not infinite solutions. It's the ordered pair 2, 4. Right? And again, this negative 14 equals negative 14 is not telling me what the answer is. It's just telling me that my answer is correct. All right. So I have this cool little table here. You should have it in your notes. I color-coded mine. Yours is probably printed in grayscale, so you probably can't see the colors. Okay? So it looks like a whole lot of information, but I want to really distill it down for a really simple piece of information. Okay, so I want to look at the final answer. So here, the final answer, so 1, 2, 3, 4. Okay, so in other words, we have in the first example, so let's give these letters just in case you're having trouble seeing the colors, right? So in letter A, the purple one, we have 16 equals 16, and that's happening what? In step 2. Okay, in example B, the orange one, we have 16 equals 15, so that's a false statement in step 2. Okay, so at this point in either of these examples, have we found values for x or y yet? Okay, and the answer is no. Okay, so again, we have a true statement in step 2. Here we have a false statement in step 2. Okay, if I look at letter C, okay, this is the blue one, right, we have a true statement in step 4, right, but that's after we've already found a value for x and y, right, okay, and then lastly, in step D, okay, we have a false statement in step 4, again, after we've already found a value for x and for y, okay, so let's analyze this and think about what this is telling us. Okay, so in case A, right, if we get a mathematically true statement before we find a value for x or y, what does that mean? Well, when you get something true in step 2, like we did in case A, that means that the final answer is, drum roll, infinite solutions. Okay, and the key here is that, again, you have a true statement before you are able to find a value for x or y. Okay, what about in case B, right, so this is case A, this is case B, the orange one. Okay, we have a mathematically false statement in step 2 before we are able to find a value for x or y, right? So when that happens, that means there is no solution to the system of equations. Okay? So now let's look at the other two cases. So case C and case D. Okay, so notice in case C and case D, right, this is happening in step 4 after, right, we have already found values for x and for y. Okay, so in case C, we've found a mathematically true statement in step 4, right? So what does that mean? That means your answer is right. Okay, so, and the answer that we have here in the nice blue font here, right, is that there's one solution at x equals 1, y equals 1. Or, if you are lazy like me, you can write it as an ordered pair, 1, 1. Doesn't matter. Okay, so again, when you have a mathematically true statement in step 4, it is very different and has a different result than when you get a mathematically true statement in step 2 before you find x and y. Right? If I've already found x and y and I'm just checking my work, right, and I get a mathematically true statement, that does not mean I have infinite solutions. It just means that all my work is good, right, and I can move on with my life. Okay, in step D, right, and this is the part that really throws students for a loop and that they have trouble with, okay, I have a mathematically false statement in step 4 after, right, I've already found x and y. So that can't mean that there's no solution. Guess what it means? It means I made a mistake, or you made a mistake. However you want to say that. You can use whatever pronoun you would like, okay? So that means I should, or you should, go back to step 1 and find and fix your mistake, okay? So let's just pause for 1 second, just for fun, and see if we can trace through this and find the mistake that was made, okay? So first, they took this equation here and they're isolating it, right? So let's see. We have x plus y equals 2. They subtract x from both sides, get 2 minus x. So far, so good. Okay. Then they put the expression in here. Okay, 2 minus x. So that is correct. Still good. Still good. Still good. So x is 1, x equals 1. That looks right to me. So let's move on to step 3. So we have x plus y equals 2. That's correct. They put that 1 in place of x, which is the right thing to do. So they have 1 plus y equals 2. Uh-oh, look what they did. They added 1 to both sides, when in fact what they should have done is what? They should have subtracted 1 from both sides. So the answer is x equals 1, y equals 2 minus 1, which is 1. Okay, and actually you could have figured that out because if you look at the system of equations, they're identical. They're the same. So again, x equals 1, y equals 1. So if you are ever working on a problem and you found a value for x, you found a value for y, you check your work and you get a mathematically false statement, right? Unfortunately, that doesn't mean you write no solution and move on with your life. What that means is you have to go all the way back to the beginning, okay, and trace through it line by line and see if you can find where the mistake happened.